Hi, welcome back to my SAP2000 tutorial class. In last tutorial class, I have discussed about how can you add different type of objects in SAP2000 software and which type of object you can use in SAP2000 software. So in this tutorial, I'm going to show you how can you draw a model by using those objects. I will show different type of example. In first example, I'm going to show you how can you model a G+3 RCC frame building. This is the grid plan of this building. Here you can see the grid spacing in X and Y direction, and this is the elevation of that building. Here the floor to floor height is 3 meter and the depth of the foundation is 2 meter and the plinth level at a 650 height from ground level. So let's begin. So before going to start, I have a request to all of you. If you have not subscribed my channel yet, please subscribe it. It will just take 1 second to subscribe my channel. If you subscribe, it will be a big support for me, so please subscribe. So I'm going to create a new model. So click on file, then select new model. Here in default setting, I am going to select default unit is as kilonewton meters centigrade, and in default material I am going to select India. And here you can see there are many number of templates. Since we are going to model a RCC frame building, so we can select grid only or 3D frame. So if the grid spacing are equal in all direction, that time you can select 3D frame template. Otherwise, if the grid spacing is not equal, then you can select grid only. In our building grid plan, here you can see the grid spacing are not equal in all direction, so that's why we're going to select grid only template. Here we are going to select Cartesian coordinate system. Here we have to provide the number of grid lines in X direction, Y direction and Z direction. In this plan, you can see in X direction number of grid line is 6 and in Y direction number of grid line is 4. So in X direction number of grid line will be here 6, in Y direction it will be 4, and also in Z direction number of grid line will be 6. And here you have to provide the grid spacing. You can see here the spacing in X direction is not same. For this 4 grid the spacing is 3 meter, but for this 3 grid the spacing is not equal. So what we will do, initially we will provide 3 meter spacing in X direction. In Y direction all the grid spacing is same, so we will provide 5 meter, and in Z direction all the grid spacing is not same here also. Here maximum number of grids are spaced at a 3 meter distance. That's why we will provide the grid spacing along Z axis is 3 meter. So along Z axis it will be 3 meter, along Y axis it will be 5 meter, and along Z axis it will be 3 meter. Here we are keeping the first grid line location at 0, 0, 0. So that's why we are going to click on OK. Here you can see the grid lines are created. Now we have to edit this grid line because these are not the correct grid, since initially we have provided the equal grid spacing. So to edit the grid lines, you have to right click here and then click on edit grid data. Then you have to click on modify show system, and now here you can see the grid line ordinate. So you can directly change the ordinate of grid line, but if you want to modify the ordinate, that time you have to calculate the ordinate of each grid line. So that is kind of, you have to make some calculation. That's why what you will do, first you will display the grid line as spacing, and now here you can see the grid line spacing here. So now we will modify the grid line spacing as per our grid plan. Now if you see the grid plan of the building, here in X direction this 3 spacing will be 3 meter, then this spacing will be 4 meter, and this spacing will be 2.5 meter. So now we are going to edit this. So here this spacing will be 4 meter and this spacing will be 2.5 meter. In Y grid data we don't need to modify anything because the all grid line along Y direction are equally spaced, but in Z direction this spacing will be modified. This will be 2.65 because the total distance from base to plinth level is 2.65 meter. Now here you can see the total height of the plinth level from base is 2.65, so that's why this spacing will be 2.65 meter. Now we are going to click on OK, and that's all. Now we have modified the grid line. Now you can see these grid lines are modified, and this is the correct grid line you can see here. One thing you will keep in mind, these are not the object, we haven't add any object here, these are just the grid line. This grid line will help to draw the model. So before add object here, we have to define some material properties and section properties. To define material properties, you have to click on define, then you have to go to material tab. So here you can see 3 material already added. So this is default material. If you don't add any material, by default this material will be added here automatically, and these two material is added because when we have started this file, there we have select material country name is as India, so that's why these two material is automatically created. And now say we are going to use M30 grade of concrete for this building, and also assume that we are going to use here Fe415 grade of steel. So since this is not Fe415 grade of steel, we have to define Fe415 grade of steel material here. To define material, click here add new material, and here select the country name, it will be India, and here you have to select the material type, it will be river, and here you have to select the grade. Here 500 550 also available, so we are going to select Fe415 and then click on OK. Now if you want to modify the material properties of this river, then select this river first, then click on modify, and here you can see this is the unit weight, default unit weight is given. If you want to change, you can change that, and also Young modulus is given here. Here you can see the minimum yield stress is given 415 MPa and minimum tensile stress is given 485 MPa, and also expected yield stress and expected tensile stress is given. I already told you in previous video what should be the value of all these four stresses, though expected yield stress and expected tensile stress will be used in advanced analysis. So if you don't perform any advanced analysis, then the time this value is not required. Just you will only check whether the minimum yield stress value is correct or not. So here we are using Fe415 grade of steel, so that's why the minimum yield stress value is 415 MPa, which is correct here. So now I am going to click on OK, then click on OK. Now we have to add frame section property to draw the model. To add frame section, you have to click on define, then go to section properties, then click frame section. So here we have to add two frame section, one for beam and one for column. Now click on add new property, and here select concrete since it is our concrete frame structure building, and select here rectangle. We are going to provide rectangle type section. Now first we are going to define beam section, so name it beam, and here you have to provide the initial depth and width of the beam. Say we are providing here 0.45 initial depth of the beam, and width of the beam is 0.3, and here you have to select the material. So already M30 grade of concrete is selected here, and in this building we are assuming that we will use M30 grade of concrete. And now you have to click on concrete reinforcement. Here you have to choose design type, it is as a beam. Here we have to select rebar material. For longitudinal bar we are going to select Fe415 grade of steel, and also for confinement bars I am going to select Fe415 grade of steel. If you want to use defined grade of rebar for confinement bar, you can add them by clicking on this plus tab, and here you have to provide the cover of longitudinal river. Here the cover is measured from center of the river. So for beam member we generally provide 25 mm clear cover. Suppose assume we are using here 16 mm diameter bar for beam, then the effective cover will be here 25 plus 16 by 2, it will be 33 mm. So here I am going to type 33 mm. Here the unit is in meter, so that's why we have to write here 0.033. Now I am going to click on OK, and now here you can see this is the beam section whose dimension is 450 mm into 300. Now click on OK. So now we have successfully added the beam section here. Now I am going to add column section. So click again, add new property, and select rectangular and name it as a column. And here give the dimension of the column. Suppose we are going to use 400 by 400 column dimension. Since the unit is in meter, so that's why we have to write here 0.4. And here the grade of concrete is selected M30, so it is okay. Now I'm going to click on concrete reinforcement. Here the design type will be column, and here you have to select the longitudinal bar. Here I'm going to select FE415, and also for confinement bar I'm going to select FE415. And here our reinforcement configuration will be rectangular, obviously, that's why we have to provide ties here. And now here you have to provide the clear cover. So for column we are going to use 40 mm clear cover, so it is okay here. And now here you have to provide the number of bar in 3 direction and 4 direction. Suppose in 3 direction I am going to provide number of bar 3, and in 2 direction number of bar I am going to provide 2. And here you have to select the longitudinal bar diameter. I am going to use 16 mm diameter bar, so I am going to select that here. And now here you have to provide the confinement bar details. Suppose we are going to use 8 mm ties, and here you have to provide some spacing. Suppose initially we are assuming that tie spacing will be 150 mm, and here you have to provide the number of confinement bar in 3 direction and 2 direction. In 3 direction number of confinement bar will be 4. In 2 direction number of confinement bar will be 2. And here you have to select whether you want to check the reinforcement data or design the reinforcement. If you select reinforcement to be checked, it means the software will not design this column. Software will just check whether reinforcement data is given by user, it is safe or not. If you select reinforcement to be designed, software will just design the section. Software will not use any reinforcement data which is provided by the user. But obviously when the software will calculate the self weight, whatever dimension you have provided, software will use that dimension to calculate the stiffness and the mass of the structure. So now I am going to click OK here. Now again we will click on OK, and now we have successfully added column section here. So now I am going to click on OK. Now we are ready to draw the model here. Here you can see two windows. This window for 2D view, this window for 3D view. Currently you can see that 3D view is selected. So now I am selecting here 2D view, and here you can see currently we are in XY plane. XY plane means we can see the plan of this building, and here we are at Z equal to 14.65. It means we are at roof level. Here also you can see that the in right side 3D view window, the roof level is highlighted. It means we are at roof level. Now first we are going to draw the plinth level beam. So if you want to draw the plinth level beam, first you have to move to the plinth level. You can move to the plinth level by clicking on this arrow. So if you click on this move up arrow button, it will move to the next grid line level. So next grid line level is set equal to 0. Then again if you click it, then you will go to the plinth level. So now we are at Z equal to 2.65 meter. It's mean we are in plinth level. If you want to directly go to the plinth level, you can go that, click on view, then click on set 2D view. Here you can write 2.65. You will directly go to the plinth level. So now we are currently at plinth level. Now we are going to draw the plinth level beam. There are many number of methods you can follow to draw the model here. If you want to know all the method, you can follow the CSI official YouTube channel. There you will get a tutorial on this topic. I'll give you the link of that channel in the description box. Here I am going to use only two draw command. One is draw frame cable and second one is quick draw frame cable. First I am going to show you how can you use draw frame cable command. These comments are available in this tool also, or you can access them from draw to draw frame cable option. In this window, first you have to select the line object type. Here we are going to draw straight frame, so you have to select it. Here you have to use which section we will use to draw the straight frame. So since we are going to draw the beam element, so that's why you have to select beam here. And in moment release section, it will be continuous because we are going to model a frame structure, so that's why it will be continuous. Otherwise, if you model a truss structure, that time you have to select it pinned. But here we are going to model a frame structure, so that's why it will be continuous. To draw the beam, we have to define start and end point of beam. Here I want to draw a beam from here to here. So what you have to do, you have to just move your mouse cursor here. So when you will move your cursor near the grid intersect point, automatically that point will be highlighted because the snap setting is on here. So you can control the snap setting from here. So by default you can see that points and grid line intersection snap setting is on. So that's why when I am moving my cursor near this intersect point, automatically this point is highlighted. So if I click here, software will consider the start point from this intersect point. So now I'm clicking here, and now this will be the end point of this beam. So here you can see the continuation of drawing mode. So if you click just here, automatically the beam drawing will continue, and if you click here, it is going on. If you want to discontinue it, just right click here, and if you want to exit from this drawing command, just click on this set select mode, or you can press escape. So this is how you can use this command tool. Now I'm going to show you how can you use quick draw frame command. To start quick draw frame command, you can click here, or you can go to the draw menu, then select quick draw frame. Here you have to select the section type and also moment release option and also line object type. And now in this mode you have to just select the grid line. Software will automatically draw a line object in that grid line. The start point and end point will be the intersect point of that grid line. So for this grid line, this is the first intersect point, this is the second intersect point. So if I just click here, so here one beam will be created. Similarly, if you click here, again a beam will be created, and if you click here again a beam will be created. If you want to draw the beam on many number of grid lines, then you can use the selection box like that. So now we are going to draw the plinth level beam by using this command. So we are going to select the total grid here from here to here, and now the beam is created. To exit from quick frame draw command, click on this set select mode cursor. Since we are using same beam section for each floor, that's why I'm going to replicate this plinth beam for each floor. So first you have to select the beam. So now I'm going to select all the beams here, and now you have to go to edit menu and then select replicate, or you can directly access this replicate command by pressing Ctrl+R. So here you can see there are 3 tabs. So since we are going to replicate in linear direction, so that's why we will use this linear replicate, and radial replicate can be used when we want to replicate something in circular direction. So here I am going to use linear replicate, and here you have to provide the increment. I'm going to replicate this plinth beam in Z direction, and floor to floor height is given here 3 meter. So that's why I'm going to put 3 meter in DZ. And I am going to replicate this beam 4 times. So that's why I have to provide here number is 4. And here replicate options are there. If you want to modify or show the replicate option, just click on here. And in this window here you can see there are 2 tabs. This first tab is for assignment data and second tab is for loads and design data. Here you can select which data you want to replicate, and in this tab you can select which load and design data you want to replicate. Through this replicate command, you can also replicate the loads and design data, but in our case we haven't added any loads or we haven't designed the member yet, so that's why only we can replicate the assignment data, nothing else. So now I'm going to click on OK, and now here I'm going to click on OK, and see the plinth level beam is replicated in each floor. Here you can see the beam are replicated correctly or not. So just go to the next grid level, that is 5.65. Here you can see the beam, and this is 8.65, this is 11.65, and this is at roof level. So now you can see the beam are replicated perfectly. Now I'm going to draw the column member here. To draw column member, I'm going to use extrude command. First I'm going to the plinth level beam. So now clicking this arrow, I'm going to plinth level. Now we are at plinth level. First I'm going to extrude the column from plinth level to foundation. Then I will extrude this column from plinth level to roof. First we have to select the extrude point. So now in our building the column will be placed in this intersect point. So that's why I'm going to select all this intersect point by using select window. And now here you can see the all the extrude point is selected. Now I'm going to use the extrude command. It is available in edit menu. Click on edit, then click on extrude, and there you will see many number of extrude options. Here we are going to use extrude point to frame option. So click on it. Here I'm going to use linear extrude command, and first you have to select the section. When the point will be extrude, which section it will use, you have to select that. So I'm going to select here column, and now here you have to provide the increment data. Since first we are going to extrude the column from plinth level to base, so that's why we have to provide increment data in DZ. Since we are going in downward direction, that's why it will be minus 2.65, and here the number will be 1. And now click on OK, and check in 3D view the column is created. Similarly, we are going to extrude this extrude point up to roof. So just select the extrude point and click on edit, then go to extrude, select extrude point to frame, and here select it column, and here put it 3 because the floor to floor height is 3 meter, and here the number of extrude will be 4 times. Now click on OK, and now see all the column are created. Now we have to assign support in this structure. So to add support, first we have to go to the foundation level. So it's mean we have to go to at z equal to 0 level. Now we are at z equal to 0 level. Now we have to select all these point, and now we will click on assign, and then go to joint, then select restraint, and here we are going to make it a fixed support. So you can click on this. For fixed support, the restraint will be applied in all direction, all three translation direction and all three rotational direction. So now I'm going to click on OK, and now see here the restraint are added. It means the support condition is added in the structure. In this model, we are not going to add any slab element. It means we are not going to add any area element. When we will design this structure, we will just consider the slab load in beam member. And to add the slab effect in this building, we have to define diaphragm constant. So now I'm going to show you how can you add diaphragm constant in this structure. We will not provide any diaphragm in plinth level beam, because in plinth level we are not going to provide any slab. So slab will be in first floor, second floor, third floor and roof also. So that's why I'm going to provide the diaphragm constant for these 4 floor. I'm going to select all node from first floor to roof. So this is the nodes of first floor, and now this is the node of second floor, this is the node of third floor, and this is the node of roof. And now I'm going to click on assign, then select joint, then select constant. So here first we have to define the joint constant. To define, click on here, and here select the diaphragm and click on add new constant. Here we are going to provide the constant axis Z here. If you click on this checkbox option, software will automatically create different diaphragm constant for each floor. So that's why I'm going to click on this checkbox option. So now click on OK, and now click on OK, and now select diaphragm 2 here, and now click on apply, and now click on OK. Now I'm going to check whether the diaphragm is applied correctly or not. So now currently we are at Z equal to 8.65. So it's mean we are in second floor. So now just click on any node, right click, and check on the assignment tab. Here in constraint section, here you can see the diaphragm 8.65. It's mean here diaphragm is added, and for each node the same diaphragm will be there. See, the same diaphragm for each node is assigned. So this is for second floor. Now go to the first floor. So now we are at Z equal to 5.65. It's mean we are at first floor level, and here check, here the constant is 5.65, and here all the nodes will be in same diaphragm. So now here also the diaphragm is same. So each floor have different diaphragm, and for same floor all the node will be in same diaphragm. If you want to remove assign data from this window, click on assign, then click on clear display of assign. Now this model is ready. Now we can apply the load on this model and we can analyze the structure. So now I'm going to show you some extrude view of this model. So I'm going to show it in 3D view. So first select on 3D view and then click on set display option, and here go to the general option tab, and here select it extrude and click on apply, and now click on OK. And now you can see the extrude view of this building. Suppose you want to check whether you have provided correct beam and column section or not, you can do that here. To check it, you have to go to the set display option. Here you have to click on general tab, and here you have to select view by color of section option, and now click on apply, and now click on OK. And here you can see that column member are in different color and all beam member are in different color. This will be the same color when we have defined this frame section property. For beam section we have provided display color this, and for column section we have provided display color this. So that's why we can see different color for beam and column section. This is how you can model a RCC frame building in SAP 2000 software. So in next video, I'm going to show you how can you model a RCC frame building, but the RCC frame building have an eccentric connection. So how can you model that eccentric connection in SAP 2000? I will show you in next video. So please like this video and share your doubt in comment section, and also subscribe my channel and also share this video. Thank you.